Hello everyone, I'm Raymond and today I'm going to present our work telling stories through multi-user dialogue by modeling character relationships. Before going into our work, it is important to understand what is storytelling and why this is important. So, storytelling is one of the most natural forms of human communication, and imagine how much more our computers could do if they could tell stories. This problem of language understanding has been gaining massive traction recently. A storytelling system needs to be able to maintain context over a much more longer period of time. They need to preserve long-term dependencies and keep track of it. This is on top of just doing remaining coherent in the short term. However, most modern automatic storytellers are plot-driven and frame the task in terms of sequentially generating plot points that narrow the story in third person. This approach does not generally place much more weight on individual characters or their interactions, which is known to be critical for creating stories. In our work, we are trying to build a character-driven storytelling system on Critical Role Dungeons and Dragons dataset CRD3. It is a dataset released by Microsoft. CRD3 is a unique dataset that contains dialogue transcripts of a small group of around 6 players role-playing various characters. Their adventures and interactions form a narrative that stretching hundreds of chapters, with each chapter forming a subplot. The original dataset contains ground truth summaries for each chapter. Here's a small example, and we can see that there are characters talking to each other, giving a summary background. Each character has its own personas with different relationships between them implicitly, and we are trying to build a storytelling system around this dataset. However, it is really difficult to maintain each character's personas consist while acting. Also, it is not easy to keep track of relationships between characters that will affect their interactions as advancing the story. To this end, we work on story continuation through dialogue instead, with the following attempts. First, we extend the datasets to enable a study of character-driven storytelling. Second, we use multitask learning to leverage character relation and personas information for better story. First, I'm going to talk about CRD3 extension. We crowdsourced descriptions of character interactions from the Critical Role wiki. These descriptions are free from text and often summarize character emotion during their interactions with another character. Here's a screenshot from the wiki. In our work, we use two different methods to assign a label for each character pair. K-mean clustering with TD-IDF representation, and VADA, which is a sentiment analysis tool from NLTK. Also, we validate the results by human labeling as well. Second, we build a system that optimizes for two subtasks: next character prediction and story continuation. For the story continuation, it's equivalent to retrieval-based dialogue, which is predicting the next character responses that continues the story given the context. In this model, two separate transformers are used to produce vector representation for the input context, and each candidate utterance for the responses retrieval task. All candidates are scored by dot product between their vector representations and the context representation. The model is trained using a ranking loss. For the next character prediction, we use the same vector representation for the context to predict the correct character from the list of all possible characters. It is pretty straightforward here. For the context which can be considered as a query, we try to encode different information for better performance. A summary of the story for the current section, pairwise relationship labels between all characters within the section, and the last entrance of character interactions. It is a single-turn dialogue system and joint optimizing with previous two losses. In order to analyze our system, we conduct two ablation studies to evaluate the effect of using any historical context and the effectiveness of each subtask and overall system. In this table, it is quite clear indicating that overall, the CLD3 dataset requires very long context to ensure effective performance. Also, we know that the performance gain is better in this dataset than traditional chit-chat dialog dataset, reinforcing our hypothesis that the CLD3 dataset is well suited to enable character-driven storytelling by focusing on interaction requiring long-term memory. In the second table, I'll talk about character prediction first. Using summary or relations as a extra information performed best through are closely comparable to the full multitask model. For the story continuation, the full multitask model outperforms all others. In all story continuation experiments, multitask strength models outperform their counterpart single task strength model. Through these results, we can infer that inferring character relationship information through both input relation clustering information as well as next character prediction helps model continuous stories while staying consistent with a particular character's persona. Overall, we extend the dataset via unsupervised model. Meanwhile, a series of ablation studies support our hypothesis that injecting model with information on relationships between characters would improve their ability to complete character-driven stories. Thank you for the listening. If you want to know more about research, feel free to check out our lab's website. Thank you.